Good afternoon. This is Dave Scott from Hydro International, and you are signed up for a webinar that's titled Stormwater Regulations and Compliance. As I mentioned, I'm the presenter today, and I'm the Technical Product Manager at Hydro International. I work for the Americas Stormwater Division, and I'm more or less a stormwater specialist, and I've had too many years to want to remember involved with stormwater regulations, looking at design manuals, involved with performance monitoring, both manufactured and non-manufactured BMPs, and I've played a pretty big role looking at product compliance and how to use the compliance to resolve specialty applications in areas like the industrial market scene. I'm also more recently a member of SWEMA, and that's the Stormwater Equipment Manufacturers Association, and I'll talk a little bit about that as we get into the presentation. The presentation today will be broken down basically into about 5 different pieces. So I'm going to talk a little bit about hydro. I'm going to give a high-level view of the regulatory scene, and I'll talk a little bit about compliance and state approvals, and specifically how the manufacturers use verification and certification programs to demonstrate compliance, and through that I'll show some examples of different BMP clearinghouses that are out there, and we'll wrap it up with some conclusions. Hydro International has been around 30 plus years now, and as you can see, we've had some quite a bit of experience with engineering structural BMPs to treat stormwater and actually wastewater and CSO. We started off as an R&D company developing vortex-based flow control treatment and equipment, and we sort of founded on the basis that application of passive vortex principles could alleviate flood and pollution challenges related to urban growth. We transitioned more into an equipment supplier, and we participate in 3 markets, primarily wastewater, CSO, and stormwater. Hydro International has over 200 employees now, spread over 33 countries. It's a great company in the sense that it gives us exposure to many water-related projects and a global perspective of challenges and solutions. Some of the applications and services we provide, of course, are going to be related to the 3 market sectors that we operate in, the stormwater, wastewater, combined sewer overflow markets. As I mentioned, we've been applying ourselves more rigorously now to the industrial market challenges. We've also acquired a company in the UK now that gives us access to hydrometry monitoring and data analysis, and we also, through that company, can offer some water engineering and resource management consultations. One of the products that we do distribute throughout the world are our vortex flow controls. They're specific to managing the quantity rather than the quality of water, and they've been very tried, tested, and proven, and they're used primarily in 3 different applications: inlet controls to try and optimize the drainage system hydraulics, outlet controls to minimize storage volumes, and then we've also been involved with some exceptional regional flood alleviation schemes. In terms of the industrial stormwater markets, we've been working with consultants now for over a decade and have had a number of projects in the metals, manufacturing, waste and recycling, transportation, energy, and quarry type applications. And most recently, we've been offering maintenance and service division that's really dedicated to ensure that what we supply will stay in compliance for the duration of the life of the equipment. When it comes to stormwater quality, we offer 4 control practices that really treat 3 different levels of, or offer 3 different levels of treatment: screening, settling, vortex separation, and filtration. And as you can see from the image at the bottom of the slide, you know, if you put that in context of solids and how fine they are, we target gross solids, coarse solids, fine solids, non-settleable solids, and dissolved solids, and obviously the equipment that can be used as you get to the finer particle sizes becomes more sensitive to flow rates. In general, there's many structural and non-structural control measures used to protect our waterways and satisfy the requirements of the Clean Water Act. And ultimately, the practices that are used is going to be decided between the designers, the regulators, to some degree the developers, and they have to demonstrate some sort of compliance with state and local permits. And so this presentation really is going to provide an overview of stormwater regulations and product assessment efforts used by industry to comply with meeting the water quality expectations. There's, in terms of the stormwater regulations, the Clean Water Act is the primary driver that prohibits anybody from discharging pollutants into waters of the United States. And they can't do that these days unless, of course, they have a NIPDES, or otherwise known as the National Pollution Discharge Elimination Systems permit. And the permit describes the limits on what you can discharge, the monitoring and reporting requirements, and other provisions to ensure that the discharges don't hurt the water quality or people's health. It's intended to sort of translate the general requirements of the Clean Water Act into these specific provisions that are tailored to each of the generators, whether it be a municipality, an industry, or related to construction runoff. And fundamentally, knowing the NIPDES permitting authority and its requirements is critical for staying in compliance, no matter what practices you intend on using. A lot more. On a state level, there are different departments and agencies, whether they be Department of Environmental Protections, Department of Environmental Qualities, different water boards. It can get quite confusing in terms of knowing who it is that you're trying to satisfy and demonstrate compliance. But at the state level, it's safe to say that they have been tasked with identifying the impaired waterways, and that's listed now as a 303D list, and it identifies the total maximum daily loads. So it identifies the pollutants that are causing these waterways to be impaired, and it also identifies some general ways that these need to be fixed. So on a state level, you can quickly identify with some of the pollutants of concern, and we'll show you some examples that are focused around TSS compared to total phosphorus, and these are also shown or described often in the stormwater management and design manuals. I'll talk a little bit more about those in a little bit. On the county level, it gets a lot more granular, and the interpretation and implementation of these guidelines forces the engineer and anybody trying to provide solutions and control measures to meet these water quality goals to further define and come up with standards on ways to demonstrate that the control practices will meet the requirements. The Clean Water Act, so I threw this slide in because when you start to look at the Clean Water Act and all of its rules, you can sort of lose sight of the importance and sometimes even the urgency about what we're trying to accomplish on a national level. And so I took a little step backwards and just said, how did this all get started? And when you start doing a little research, you find that the Cuyahoga River in Cleveland was basically the impotence of the Clean Water Act that was started in 1972. And I found an article with the New York Times and reported things like there was no life, the water was chocolate brown, there was a 3-inch oily layer that would float on the surface, and it was a fire hazard. In fact, it had caught fire 13 times between 1869 and 1969. I think it was on a 100-year period. And while those sort of days are over, I expect, you don't want to lose sight of what we're trying to accomplish and what these sometimes frustrating rules can try to force you to do. There was another little brochure that I stumbled across, and it sort of emphasized the importance of the Clean Water Act and the funding needed to protect our waterways. And I felt like this brochure sort of shows you the good and the bad. And I think when you're caught up in the regulations, you kind of lose sight of what we've actually been able to accomplish over these years. That being said, in 2012, the EPA noted on its 40th anniversary of the Clean Water Act that the glass is only half full. The EPA estimates that about half of our rivers and streams, 1/3 of lakes and ponds, and 2/3 of bays and estuaries are still classified as impaired waterways, in many cases not clean enough for fishing or swimming. So just because the rivers aren't burning does not mean that they are alive, and we should be spending, continuing our efforts to change that. And I'm going to take just a quick moment, just if you click on this a link that's going to take us over to SWEMA website, which is the Stormwater Equipment Manufacturers Association website. And I'm just going to point out quickly, this is the only industry organization for manufacturer treatment devices. It supports the regulatory and engineering communities in implementing the Clean Water Act, and it does this by providing the sort of direction for development of standards to ensure compliance. And I kind of got ahead of myself a little bit here, but there's a advocacy link on the website where you can find policy and position statements. Just on the left, see the advocacy tab, And in this case, I urge you to read a letter submitted to the EPA supporting the continued funded needed to properly maintain the Clean Water Act, because you may not be aware that the current administration has signed an executive order aimed at removing a rule in the regulations to redefine what water bodies fall underneath the Act. So getting back to the presentation itself, on a state level, I had mentioned that the way that a designer and an owner can address meeting these requirements that are laid out in a very general sense at the federal level. Each state has created its own guide or sort of recipe that allows the consultant to develop a stormwater management pollution prevention plan, or SWIP. And within the SWIP, the newer ones are starting to describe I call a standard set of permit requirements, and that sets off a starting place to look at in terms of your design. It also includes some general planning approaches that you can use to control and treat runoff, and it identifies standard stormwater practices that are deemed acceptable. Excuse me. The SWIP itself describes practices that are being used at a site or project location, and every construction activity, MS4 permit, and industrial facility needs one. But given each state or MS4 is in charge of its own permitting, the SWIP is going to be site specific and may include practices that are found in design best management practice manuals. But there's many practices like manufactured treatment devices to utilize when the approved options just aren't practical. So the question that I'm leading to now is really, how do I use manufactured treatment devices, and how do I stay in compliance when I want to use them? So over the last 10 years, there's been a lot of work by the manufacturers, SWEMA, and consultants, academia, and the like to form stakeholders to address testing both in the lab and in the field. And in the lab, there's still a lot of testing that goes on that's what I would call in-house. And it's kind of it's in-house because a manufacturer like ourselves, Hydro International, we have our own laboratory and hydraulics lab where we can conduct our own testing. And most of the testing that we do is independently witnessed, observed, and later verified and sometimes certified. But the main point is that the procedures and methods, if they are truly homegrown for in-house lab testing, it might not be the type of data that will allow you to be in compliance when you submit in your design plans. And I'm going to show you a couple of verification programs in a little bit that will explain what I mean by that in more detail. Just focusing on field monitoring, there was a guideline that the EPA put out in 2002 that has sort of allowed field monitoring to become standardized. And there's no doubt that there's a lot of nuances in field monitoring that is specific to a given site and a given practice that you are trying to monitor, but they have brought a lot of standardization to how you think about and plan for your monitoring program. And you know, it's safe to say that there's only 4 state programs. There's one in New Jersey that's often referred to as TARP, Technology Acceptance Reciprocity Program. There's one out in the West Coast in Washington, TAPE program. And then there's Virginia and Georgia. And all 4 of these have test protocols that you can follow to monitor your control practice. But fundamentally, they are based on the guidelines that EPA has issued in 2002. When it comes to laboratory testing, as I mentioned, there sort of is a homegrown test protocol that floats around that most of the manufacturers follow, and you know, it's a general describes a general particle size distribution that you're using and methods that you're going to use to sample, as well as the methods that you'll use to analyze. And one of this page is actually talking about the Washington DOE Department of Ecology verification program, and they have a pretty comprehensive website, and they've got a process in place that combines both lab and field testing. And so when you come to their website, you can search on control practices, and depending on the category that they're going to be used for. So as an example, you can see these tabs where my cursor is running across. Pre-treatment, oil, enhanced, which is removals of dissolved metals, basic, which is based on TSS, phosphorus, and then of course construction runoff. And they have very prescribed requirements for each of those different categories. And this is just showing you the upflow filter. When you click on the link for a given practice that's underneath one of those categories, it will give you a report that is based on all the information that the manufacturers have submitted. And the type of information that's in here is critical because it not only sets the standards for how that piece of equipment is going to be sized in terms of acceptable loading rates. It also describes what calculations are needed to use in order to determine how to apply those loading rates. And what that really means is that even if you're on the list, if you're not designing the equipment correctly and sizing it correctly, you potentially can submit a plan that will not have a control practice that is in compliance. So one of the benefits of working with folks like Hydro International is that we are all too familiar with all of the nuances in those verifications, and the beauty of it is that we can ensure that what we do propose as a control practice will meet the requirements as prescribed in the verification and is posted on the website. Moving on to another clearinghouse, which is Virginia BMP Clearinghouse. This one is actually focused on getting or achieving a phosphorus rating. So each of the manufacturers will submit both lab and field testing data to the DEQ, who reviews what you are submitting and the data set, and they have to determine what total phosphorus rating that device will get. There is a maximum phosphorus rating you can get, so even if your product can get 70 or 80% removal of phosphorus, they're going to cap it at 50. And they currently will accept TSS data for a 40% total phosphorus rating until that device has been monitored and can demonstrate removals of phosphorus. So following some links in that website, you can look up different control practices, and I'm showing two different types that we offer: the first defense, the downstream defender, and we have the upflow filter with CPZ media. And you can see the efficiency rating that is allowed by the state, 20% for the separators and 40% for the upflow filter. So this is the beginning steps to knowing whether or not you can use a manufactured treatment device as a control practice to stay in compliance with your permits. Once again, I'm going to emphasize it, safe to say there's a lot more work to be done in terms of the details to size it correctly and make sure that it's going to hydraulically meet the general permits requirements. Another big clearinghouse for manufacturers, which is mostly based on lab testing these days, but they do have some field studies that have been verified by NJCAT, is the New Jersey Corporation for Advanced Technology. And this this company does provide verification of a number of products outside of stormwater, but they have a process in place that has been standardized and vetted now since I've been in the business. So I think they've been going now strong for about 15 or more years. I'll just go back one sec. The clearinghouse itself is very useful, but there's a lot of information. And so if you go back, so when you look at the website, when you get a link to it, you will find that you can download different reports similar to what you could for the DOE. Oh, we just lost our spacing there.
Sorry.
That's right. Yeah, 24. Go one more. Oh, sorry, go back. And so when you download the reports, you can find a lot of information that has to do with the models, how they're scaled from the tested unit, and the loading rates that are acceptable. And once again, other non-performance related attributes that might be related to maintenance. Go one more. After equipment has been verified by NJCAT, the information is sent over to the New Jersey DEP, who then certify what's been verified. And there's the nice thing about the certification, I don't know if you can click on one of the links now. You can look at a certification letter, wrong one, but the certification letter then provides which models have been certified, and at the end of the report includes the maintenance requirements and any other design requirements. So the certification is a summary of the verification, but it's a good way to understand a lot of information that is contained in the verification reports. One more. There are also non-state or municipal verification entities, and an example would be Indianapolis. And the city of Indianapolis has developed its own testing criteria and its own process for manufacturers to be vetted and approved. And essentially, it allows the manufacturers to be included on a list that you can reach on the website. And once again, it does describe the product name and the different model numbers and an associated maximum treatment flow rate. And in this case, it's relevant to showing compliance with 80% removal of TSS. Go to the next one. And I wanted to just show one more. This is for a municipality in Tennessee. And what was interesting about this and why I thought it useful to show is that it's pointing directly to the New Jersey certification data. So they've done a nice job in terms of identifying which products have been New Jersey certified, and they've summarized quite well in terms of models and treatment flow rates, and they've also provided the rating that it's been approved for with links to the information on the websites. So there's different ways that municipalities and states are creating I'll call them lists, but they're essentially mechanisms for manufactured treatment devices to be approved or screened so that you know that if you're using them per the design requirements, you're going to stay in compliance with your permits. Next one. I'm going to show one other list, last one. This one fairly new. It's out in California, and the reason I'm showing it is because it's not about the phosphorus or the TSS that you normally get rated on. This one has more to do with can you capture particles that are greater than 5 millimeters. And out in California, their total maximum daily load, at least in a lot of the municipalities, have driven a TMDL for trash of 0, and that is how over the years they've come up with certifying products that can manage that requirement. It is safe to say that just because you can meet the full capture requirement doesn't necessarily mean that you're going to meet other requirements that are on a local level. So just some trends that I thought would be interesting to mention. Very recently, there's a Stormwater Manufactured Treatment Device Certification Guideline Manual that has been published through the ASCE. It was edited by George Kuo, who's from down in Rutgers University in New Jersey. And what I found interesting about this idea was that with this guideline, potentially you could see how every state, region, or regulatory body could have its own verification process. And in some ways that already exists. There's a lot of times when we go into new municipalities that have their ideas themselves about how to approve different products or practices, but this, there's no sort of standard methods in place, and this guideline attempts to standardize the verification and certification process. One more. And they've broken it down into 7 components that you can evaluate for yourself so that you offer a standardized way of conducting lab testing, looking at scaling from the tested unit. It provides a lot of technical information about how to analyze your data, evaluate it, and then report it. And it even has sections in there about inspection and maintenance, and the types of requirements that should be considered as a part of your certification program, if that's what you want to do. So once again, what's just sort of come out big picture in terms of trends. Here we've got a certification guideline manual out that potentially could be used by every municipality or county in every state in North America. And one kind of shivers at that thought, because now as a manufacturer you might have to meet different requirements for every single municipality. Go to the next one. And so on another level, to prevent that from happening, in 2016, the end of last year, the International Standards Organization, ISO, published a standard for technology verification that defines the assessment process for verifying innovative technologies. And the only piece that's a little bit vague for the manufacturer is that they don't have, as a part of that standard, a prescribed testing protocol to follow. But aside from that, the beauty of going down this pathway is that you would have one organization or many organizations that can implement a process that follows the ISO standard, and there would be one list that everyone would go to see what those verifications say and to know whether or not what you're proposing is going to keep you in compliance. So it's a very different way to look at it, and one probably that SWEMA promotes more than having every municipality in North America having its own verification program. One more. Once again, just to go back to SWEMA, the Stormwater Equipment Manufacturers Association, underneath advocacy, we have, it's well worth just taking a little peek around the website and reading some of the policy and position statements, because this particular topic and the trends that I just described are discussed in a white paper that was published a couple of years ago. And fundamentally, I think everyone can agree that it is important to have performance-based standards, but we need it to be consistent. And if that's done, then it makes everybody's life easier, and it brings about some coherency within the industry. So that's about all I had, really, as far as the presentation. I wrap it up with a couple of conclusions. The first one being, don't lose sight of the importance of the Clean Water Act. I think that a lot of our waterways right now appear to be reasonably clean, especially when you compare it to the days that the days that were back in the 1950s with rivers catching fire. So there's been some huge gains there, but we're still falling short in terms of making these waterways live again. It really is critical to understand your NPDES permit requirements. Do you need full capture? Do you need to be targeting TSS? How are they going to define TSS? Does that mean that I'm going to use a filter or a separator? Or am I chasing total phosphorus? These are things that you have to look at on a site-by-site basis. It's also important to understand the potential sources of pollution and develop a stormwater pollution prevention plan, or a SWIP, that is site-specific. And when taking advantage of BMPs that may not be readily approved, it's easy now to rely on verified third-party testing to demonstrate compliance. And take the time to appreciate the differences between lab and field testing and what makes sense to use for each of your applications. Because ultimately, when the reviewer sees your SWIP, the information that's in there is going to play a big role in terms of whether or not it gets approved or not. Well, that's the end of the presentation today. I'd love to get your feedback. The PDH certificates are going to be emailed out by the end of day tomorrow, and we'd love to get your feedback, so please take the survey. And the benefit of that will be a random draw to win and a couple little goodies that you see in the slide there. Thanks so much for your time. Please give me a call or send me an email if you have any questions or want additional information. Hope the rest of your afternoon goes well. Bye-bye. It's weird.